Welcome back to part 2 of the introduction and history of the golden ratio and Fibonacci numbers. So in this slide, we talk about the different names of the golden number. And here pictured is a beautiful starfish exhibiting a 5-pointed star, and 5 is a Fibonacci number. All right, so the 21st Greek alphabet letter is used as the symbol for phi. All right, so other names include the golden mean, the golden section, the golden number, golden ratio, which is the most popular term used, the golden proportion, golden cut, extreme mean and ratio, the mean of Phidias, divine section, and medial section, as well as the divine proportion and phi, which is also a very popular term. So now we talk about Fibonacci numbers in history with a focus on the 6th century to the 19th century. So the ancient Indians, hats off to them, because they are the reason why we use numbers 1 through 9 and 0. So we use those every day. It's how we do our computation, and the world over has adopted this number system. And we exchanged it for Roman numerals, which are clunky and difficult to use for computation. So in the 6th century India, the ancient Indians knew about Fibonacci numbers. So in 1202 AD, Leonardo of Pisa, also known as Fibonacci, introduced India's number series to the West in his book Liber Abaci. And here you can see a page from that book. So, and Liber Abaci is Book of the Abacus, is what it translates to. And this page here talks about the famous rabbit sequence, which we'll talk about in just a few minutes here. So, and this introduces the Fibonacci number series in this rabbit sequence story. And the Fibonacci numbers include 0, or they begin with 0. Actually, it can either begin with 1 or 0. I usually start it with 0. So 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and this is an infinite number. So, and the sum of the first two gives you the next number, and that's how you get each number thereafter. So, whoops, let me go back. So the 19th century Fibonacci sequence was first named such by number theorist Edward Lucas. All right, the Fibonacci number series history overview. So we have here a portrait of Leonardo of Pisa, one of the main portraits that we find on the internet of him. It was actually made by a medieval artist, so we don't really even know if it's how accurate it is. The Fibonacci number integer sequence, again, is 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 55, 89, 144, and there's actually contests where people memorize these numbers and see how far up into the sequence they can memorize them. And pi is another number that people like to have contests with. I have a friend that can recite hundreds of numbers in pi. It's pretty awesome. So starting with the first two numbers, as we stated earlier, each subsequent number is the sum of the previous two numbers. So related to the golden ratio by dividing each larger number by the previous smaller number. So if you divide 1 divided by 0, 1 divided by 1, 2 divided by 1, and as you go up, go higher and higher in the sequence, it gets closer and closer to the golden ratio, which is pretty awesome. So going through the sequence, the numbers, as I mentioned, get closer to the golden number. The Fibonacci pictured here, helped spread the Hindu-Arabic numbers that we use today across Europe through his writings. All right, let's talk about the Fibonacci rabbit sequence. So in his book, Libra Bocci, Fibonacci presented a story problem about the speed of ideal rabbit breeding in a year. So here's how the story goes. So if a pair of newborn rabbits, male and female, one male, one female, were placed in a pen to reproduce, how many pairs of rabbits will they have in a year? So, and you have to follow certain rules. So each month, the same pair, the same original pair, reproduces a new pair, always one male and one female. Each new pair can breed by their second month, and the rabbits never die, and the answer is on the following slide. So these are ideal situations. So here we go. We begin with one pair who are too young to reproduce in the first month and this month here, but after 1 month they produce a pair. All right, and after 2 months, 3 pairs. After 3 months, 5 pairs. After 4 months, 8 pairs. All right, and then here you can see the answer, the bottom. So here we have a monument of Leonardo of Pisa, Fibonacci, made by Giovanni Paganucci, completed in 1863 in the Camposanto di Pisa. And then here's a close-up of the statue. All right, the golden number and Fibonacci numbers history timeline, Bonnet and Ohm. So we have a picture of Charles Bonnet, and there's Martin Ohm. So in 1720 to 1793, Charles Bonnet lived. He pointed out plant spiral phyllotaxis going clockwise and counterclockwise were frequently 2 successive Fibonacci numbers. So if you love to garden or observe the plants around your house, you can observe this phenomena. All right, so in 1792 to 1872, Martin Ohm is believed to be the first to use the term goldener Schnitt or golden section. All right, golden number and Fibonacci history timeline, Lucas and Barr. Here we have Edward Lucas, and he lived from 1842 to 1891. And he was a French mathematician. He gave the numerical sequence now known as Fibonacci sequence its present name. In the 20th century, Mark Barr suggested the Greek letter phi, the initial letter of Greek sculptor Phidias's name, as the golden ratio symbol. And here we have the 21st letter of the Greek alphabet representing the golden number. All right, and finally we conclude our timeline here with Roger Penrose, who was born in 1931, and he still lives. Here's a photograph of him. All right, he described symmetrical pattern with golden ratio in aperiodic tilings field. His work led to quasi-crystal discovery, which exhibiting previously thought impossible crystal symmetries. So here in the background, we have an oil painting by Urs Schmidt in 1995, showing Roger Penrose's tiling using fat and thin rhombi. So really awesome there. Okay, and you can learn more about the golden number and Fibonacci by visiting these links here from my class Math Art virtual library website. Here are references I used, and thank you so much for watching.